We have totally three layers in the Snowflake architecture. Three layers: uh, cloud service layer, query processing layer, and then database storage layer. We'll discuss one by one. We'll go with the database storage layer. So what is this database storage layer? Okay. See, this is the layer where when you load the data into the Snowflake, the actual data it is going to store into the database storage layer. Now, you'll see how the data is going to store in the Snowflake. Suppose let's consider, guys, whenever you load the data, into the Snowflake, okay, suppose this is the table T1, this is the table T1, and your table is looks like your table is looks like this. Whenever you are trying to load the data into the example, I'm saying into table T1, your table is looks like combination of rows and columns, but internally how the data is going to store in the Snowflake. Whenever you load the data into the table T1, the data is going to store in the multiple micro partition, continuous multiple micro partitions. What is this micro partition? Micro partition is storage component in the Snowflake. Example, how you are going to place your clothes at your home in the cupboards, how you are going to place things in your home, placeholder, like that. Micro partition is the storage component in the Snowflake. So each micro partition size is 500 MB. Whenever you load the data into the table in the Snowflake, the data is going to store in the continuous multiple micro partitions, and once the data is going to load into the multiple micro partitions, these multiple micro partitions multiple micro partition information will be written into the multiple micro partition. Details will be written into the metadata tables in the Snowflake. Suppose let's consider you have loaded the data into the table T1. Table T1 has a column type and then name, country, and then date. All these 4 columns data you are going to store into the multiple micro partitions. Now, for this table data, 4 micro partitions are occupied. And then, so these are the values. Now, in the Snowflake, there are metadata tables where this metadata information will be written automatically. That is means for the particular table T1, 4 micro partitions are allocated. 4 micro partitions are allocated. For each column, you have a type, you have a name, you have a country, you have a date. For each column, what are the rows are written into the each micro partition, all these things. Suppose let's consider you have a date column. In the particular micro partition, suppose 10 records are inserted. 10 records are inserted into the one micro partition. What is the minimum value of the column? What is the maximum value of the column? All those things will be written into the micro partition. And this information in metadata tables. So next, whenever you query a data for this table, select star from table T1 where name equal to y. Now, so name equal to y. Y is the one value, and where is it another value? Two values. So you have two records. You have two records in the table, and then you have two records y. This is the y1. This is the y. Two records. Nothing but the micro partition 3 and then micro partition 4. Two micro partition 3 and then micro partition 4. Those two micro partitions are having a records with the where name equal to y. What it will do, optimizer in the Snowflake, while scanning or while retrieving a data for the particular query, select star from table where name equal to y. By using a metadata tables, already in metadata tables, you have a information like in which micro partition, what records are available. By getting that information, the optimizer is directly going to read the particular micro partition. Now, name equal to y. Y values are available in the micro partition 3 and then micro partition 4. So instead of scanning the four micro partitions, it is going to read, optimizer is going to read only a micro partition 3 and then micro partition 4 with the help of the metadata tables. Now, what is the advantage here now? So it is skipping the scanning or reading the whole micro partitions. Suppose you have a n number of micro partitions, you have a huge data in your table, like terabytes of data. For that, n number of micro partitions will be allocated. While reading a data from the table for the particular condition, if it is going to read all the n number of, it is going to scan or it is going to read all the n number of micro partitions, means then it is going to kill the performance of your SQL code. So for that, Snowflake has introduced to improve automatically the performance of the SQL code like this. Instead of scanning all the micro partitions, it is going to scan only a required number of micro partitions and bring the data for you, so that you are going to see the very good performance. You are going to see the very good performance improvement in the Snowflake. Very good performance improvement in the Snowflake while reading the data. Guys, this point is clear or not? How the data is going to store in the micro partitions, how the data is going to read, how we are going to benefit the performance of SQL code while reading a data from the micro partitions. Getting or not getting, clear or not clear? Tell me, guys, so that we will continue further discussion. Guys,
how the data, a particular row is stored in this, split into this 4 partitions.
how the data is going to split. Usually, one micro partition is 500 MB. Okay, one micro partition is 500 MB. So how much data you have in your table? How much data is there in your table? according to the table data, okay, so that much of or those many number of micro partitions will be occupied automatically, right? So how the data is going to split means first 500 MB of data will be loaded into the first micro partition. Once this is completed, then again it is going to look into the second, third, fourth, fifth, like that. Make sense, guys? Clear or not clear?
Can you explain with one single row how the data distribution is happening?
See here. See. Next point. Actually, so I am about to explain about how the data is going to store in the column format. That's fine. See here. Type, name, country, and the date. These are the 4 columns in the table. Yes or no, guys? Hello.
Yes.
Yes. So just see the micro partition one. The column has the data is stored in the column format. Data is stored in the column format, not into rows into columns. Now type, name, country, date. These are the 4 columns. Now first value, type is 2, name is A, country is UK, date is 11/2. First value, first record is 2, second first value is 2, second value is A, third value is UK, and fourth value is 11/2. And then second, where is that? 4. So second record is this. This is the value, this is the value, this is the value. And then third value. This. Next, B. Next record is this one. Next record is this 2, C, PP, and then 11/2. So like this, see, sequentially, the data is stored in the micro partitions, right? Once this 500 MB of data is filled, once the 500 data of filled into the one micro partition, then it is going to shift into the next micro partition. So that's how it is going to store. Clear? Guys.
Yes, clear.
Yeah. So now, one second, guys. So now we have seen what is the advantage. We have seen what is the advantage when we store the data into the micro partitions. Now we'll see we'll discuss how do we get the benefit when the data is going to store in the column format, right? Yes, usually in other database, how the data is going to store, guys? How the data is going to store? In which format?
Record by record.
Sorry?
Record by record. It's row format.
Yeah, it is going to store in column format. It is going to store in rows and then column format. It is going to store in rows and column format, right?
Yes.
But in the Snowflake, data is going to store in a column format. That is what I explained you. Type C. If you usually in regular format, column names will be top. Type, name, country, date, like that. Right, guys. Usually in regular database format, data will be stored in the rows and then column format. The columns will be top here. Type, let's say like this. Type, name, month, country, date, etc. So now in this Snowflake, they have changed the storage format. How the data is going, the data is going to store in the column format. The advantage here see the first record 2A UK 11/2, 2A UK 11/2. Second record 4C some SP and then 11/2. Now, what is the advantage here? Suppose as the data is stored in the column format in the Snowflake, if you want to read the first record now, okay, then it is going to scan only one particular micro partition because the first record is available in the first record is available in the first micro partitions, or this highlighted record is available in the last micro partition. Highlighted record is available in the last micro partition because as data is stored in the column format now, it is not stored in the regular format. If it is stored in the regular format, even a single record itself will occupy a multiple micro partitions because first two columns data will be stored in the first micro partition. Second two columns data will be stored in the second. Third column data will be stored in the third micro partition. Single record data is going to split into the multiple micro partitions if the data is going to store in the regular format, columns and then rows format. Now, as they have changed the storage format, your particular one record, see, in regular format, the data is going to store in the vertical format. Now it is a horizontal format. So now if you want to read this last highlighted data, then it is going to scan only a one micro partition, guys, because this entire data is available in the one micro partition only. This record is not split into the multiple micro partitions because data is going to store in a column format. One record is going to fit into the one micro partition. Based on the metadata tables information, the optimizer will look into the particular micro partition where exactly the required record is stored in the micro partition. It is going into that particular micro partition, bring the data for you. That's how you are going to benefit while reading the data from the micro partition. So this is how again next. This is how the data is going to store. On top of it, guys, how many of you aware the index concept in the other database? Index concepts in the other database. How many of you know indexes in any of the databases? Guys, yeah, like this in Snowflake, we have a concept called we have a concept called clustering keys. So the concept they have replaced here. If you create like that indexes here, the same thing we can pronounce as a clustering keys. Again, if you create clustering key, suppose here clustering key has created on top of name column. Whenever the clustering key is created on top of the any column, that column data physically sorted, and then that sorted value is going to store into the micro partition. Now earlier, if you query a data, select star from table T1, where name equal to y, the y values are available in the micro partition 3 and then micro partition 4. But now you have created a clustering key on top of the name column. The data is sorted in a physical data is sorted in a ascending order. That ascending order data is going to store into the micro partition. Now see here that value y, both the records are available in the micro partition 4. Earlier, to bring the data to bring the two records, it has to read the micropartition 3 and the micropartition 4. Now, then the optimizer is directly going to read the data from the micropartition 4, and then it is going to read the data from the micropartition 4 and then bring the data for you. Again here, still it is going to save the scanning of the micropartition. Earlier it needs to scan two micropartitions. Now, as you have created a clustering key on top of your name column, the data is sorted. The data is exactly sorted based on the how the data is sorted in the ascending order. The same thing here: A, B, C, X, Y, Z. So now it is going to read only a particular micropartition 4 and then bring the data for you. So still it has the advantage to read the data when we create a clustering key on top of the table. So this is how your, one second. Where is that? One second, guys. Snowflake introduction. I have some content here. One second, I'm looking for that seminar on the architecture. Snowflake. Okay. See, database storage layer. Storage component of the Snowflake. When you load the data, data will be stored in a continuous micropartitions in a compressed way. Size of each micropartition maximum 500 MB. Data will be stored in column format. It will store the data both structured and then non-structured data. Structure means as usual meaningful data. Non-structure means semi-structure means JSON data. So this is about the your storage layer, guys. This is about your storage layer. Now tell me, you are clear or not clear on storage layer? If you have any gaps or doubts, let me know. I will explain you. Any doubts? Clear or not clear? Any gaps?
Sir, can we see this micro partitions?
Micro partitions?
Can we see this micro partitions just like a table?
No. That is internal thing. We can't able to query. We can't able to see that actually. We can't able to
Okay.
see how the
Okay.
data is going to store in the micro partition. That is we can discuss, but we can't query. But you can able to see the metadata tables. I will share all those metadata tables. But you can't able to see that micro partition in the Snowflake.
Okay. Thank you.
Guys, any other question? Any other questions, guys? Chalo. Now we will discuss about the query processing layer. Guys, yesterday I mentioned one point. We discussed one point in a high level. Virtual compute warehouse. Have you remembered? Yesterday I mentioned one of the feature virtual compute warehouse as part of the features. Yesterday I explained about the virtual compute warehouse. How many of you remembered that one? Guys, How many of you remember? Yesterday I explained about the virtual compute warehouse. Chalo. See, a query processing layer. Query processing layer is it's all about the hardware resource. It's all about the hardware resource. In a Snowflake, we have a concept called virtual compute warehouse. Virtual compute warehouse. This virtual compute warehouse is the hardware resource in your Snowflake environment. And this virtual compute warehouse is one of the object in the Snowflake. How you are creating a table, how you are creating a database stored procedure like other object, same like you are going to create a virtual compute warehouse in the Snowflake, which is a hardware resource to your Snowflake environment. There are no physical components in the Snowflake for the hardware resources. Everything is virtually they have provided as a hardware resources. What is this virtual compute warehouse? How you are going to create? How you are going to create? See here, in this Snowflake, complete the hardware resources are replaced by this virtual compute warehouse object. There are no physical components. According to the requirement, according to the requirement, you are going to create this virtual. Suppose let's consider you are working for the project. Based on the number of users, based on the data size, how you are going to process the data in your project. Based on that, you are going to create a virtual compute warehouse with the different sizes. You have a virtual compute warehouse with the different sizes. See, virtual warehouse size, X small, medium, large, X large, double X large, triple X, 4X, like that. Based on the requirement, you are going to create a one virtual warehouse with the size of either small, either medium, either large, etc. Now, once you create a virtual compute warehouse in your Snowflake environment, for all the requests, whatever you want to execute, see in the on-prem servers. What is the meaning of on-prem servers, guys? What is the meaning of on-prem servers? Guys, what is the meaning? At least try to open. Whether it is right or wrong, try to open. I don't want
Physical
silent.
setups install in
Yes.
premises.
Physical servers and then hardware components. Physical servers are maintained with the hardware components. Yes or no?
Yes.
Yeah. Now, in on-prem servers also, suppose you have a SQL Server data warehouse. You have submitted as an end user. You have submitted the IO request to the SQL Server data warehouse to bring the data, to get the data from the SQL Server data warehouse. You have submitted input and then output request. You have submitted the super complex code to the SQL Server data warehouse to get the result. Now, in the on-prem servers, without your CPU, without your hardware component, so how the data is, how the query is going to execute with the help of the CPU, hardware resources, CPU, with the help of the CPU, there you have a processors, where you have processors within the CPU. Those processors are going to execute your SQL code and then bring the data from your physical data. Like that, there in the on-prem servers, it is going to use that hardware resources. Like that, in the Snowflake environment, even if you execute your SQL code in the Snowflake environment without this virtual compute warehouse, you can't able to execute or you can't able to submit any of the request into the Snowflake, and then you can't able to execute any of the SQL code in the Snowflake environment. Okay. For any kind of the request you are submitting to the Snowflake environment, either it is a data retrieval, data processing, or data load, whatever it is, for all the requests, without the virtual compute warehouse, you can't able to complete the any of the request, because this is the hardware resource in the Snowflake. If you want to execute your IO request, what is the meaning of IO request, guys? What is the meaning of IO request? Guys, why silent? Simple thing, na IO request. What is the meaning of IO request?
Input output request.
Input output request. You are submitting a query to the database, that is a input, and you are expecting a result from the database, that is output request. It is returning from the database, that is output request. Like that, whatever the request you are going to submit, to the Snowflake environment, without you, for sure you require a virtual compute warehouse. And virtual compute warehouse are created. Virtual compute warehouse is created based on the size. According to your project requirement, you are going to create a virtual warehouse with these many different sizes. Now, example, in your house, you are using a electricity, right? You are using a current, you are using a power. How you will get the bill? Based on the number of units, how many units you have consumed at your house. So based on the units, the month end or first week of the month, the bill will be generated. So based on that, you are going to pay the amount to the electricity board. Like that, suppose let's consider you have created a one virtual compute warehouse with the medium or else with the small size, with the extra small size, and you started using the virtual compute warehouse. Automatically, see, you created virtual warehouse and you started using that virtual warehouse in your Snowflake environment. So based on the per hour, for 1 hour, it is going to generate the one credit. Per 1 hour. For 8 hours, it is going to generate the 8 credits. So based on this credits, so this is like a units, how you are consuming your electricity. Like that, based on the credits, how many credits it is generated for the 1 month. So for that, you are going to pay the bill. See here, this is the X small virtual warehouse. It is generating a 1 credit for 1 hour. If you are using a 8 hours, it is going to generate a 8 credits. You are using Snowflake environment for the 1 month, 20 days, 20 working days, 18 to 20, 160. 160 for the 1 credit, 160 credits, you are going to pay to the Snowflake environment. Always the pricing will be happening. On Snowflake based on the storage space occupied for your business data plus number of credits you have consumed from your virtual compute warehouse. Based on these two factors, you are going to pay the amount to the Snowflake environment. So, like that, if you create a virtual warehouse with the different virtual warehouse size, so based on that virtual warehouse size, those many number of credits will be generated. For those credits, you are going to pay to the Snowflake environment. Now here the beauty is here. Is in the Snowflake and then virtual compute warehouse. Suppose let's consider you have created a virtual warehouse size with the X small virtual warehouse size, and then you started using. In the very early morning daily, your ETL batch jobs are running, and then data is loading into the Snowflake environment. That is a peak hour. That is a peak hour for you actually. Daily, some hours daily you are loading a data in the morning 6 a.m. You will get the files. You will get the source files from the your client, and then they are going to place into the S3 bucket, and then from there you will pick the data and then load the data. At that time, that is the peak hours. So on at that scenario, your Snowflake environment will become a little bit slow due to that requests are heavy, and then it is processing a huge data. And at that time, whatever the virtual warehouse size with the XML you have created, that is not sufficient. It requires still more compute power. It requires still more compute power. So in that scenario, Snowflake has provided the beautiful option. Whenever you required, on the fly, without. Suppose let's consider, guys, in the on-prem servers, if you want to upgrade the hardware resources, then what needs to be done, guys? Suppose already existing hardware resources are not sufficient. It is not your data warehouse is not responding properly because of the outdated hardware resources. Then what you need to do? What you need to do usually in the on-prem servers? Guys, manually the hardware resources should be upgraded. Like that, hardware resources should be upgraded. Like that. So here in the Snowflake, at the particular time, while loading the data, the Snowflake environment is becoming a little bit slow, and then facing some issues. It is taking too much of time. In that scenario, so here, without stopping any request, without impacting the others' work, impacting the your work, you can able to increase the one virtual. You can able to increase the virtual compute warehouse from one size to the another size. Suppose earlier the virtual compute warehouse was created with the X small, and then it is taking little bit time to complete the process in the very early morning, because there are data load requests are executing. In that scenario, without stopping that process, you can able to increase from X small to the small. So this concept can be called as a scale up of the virtual compute warehouse. Scale up is you are increasing a virtual warehouse size from one size to next size. That is the scale up. You can call it as a scale up. Scale down, you are decreasing. So on the fly, you can able to increase from one size to other size to improve the performance of your current request. Once the work is completed, then again you can scale down from small to the X small. Like that in the Snowflake. Okay, 1 second.
Sir, it will happen. Sir, sorry to interrupt you. Sir, it will happen automatically, or someone has to make the request of a particular time when the data is getting loaded?
Yeah, see, that is what here I will come to the next point actually. Here in the Snowflake, at the time of particular you are executing a multiple requests, and then if you see the slowness of your environment, directly you can increase. No need to request. Directly you can increase from X small to small size. That is the one option. If you create a virtual warehouse size, if you create a virtual compute warehouse, you have two types of virtual compute warehouse actually. Standard one, and then clustering virtual compute warehouse. if you create a cluster, so far I'm talking the standard virtual compute warehouse. In that virtual compute warehouse, you will define the virtual warehouse size, and then you are going to create virtual compute warehouse. The clustering virtual compute warehouse means there you are going to define a minimum cluster and then maximum cluster. Still, that is advanced level of the virtual compute warehouse. You are going to define a virtual warehouse size. Additionally, minimum and then maximum cluster, minimum and then maximum clusters you are going to give in the virtual compute warehouse. So in that virtual compute warehouse, you no need to manually increase the virtual warehouse size, as you have defined the minimum and then maximum clusters. Automatically, by using those clusters, automatically the required hardware resources are provided, and then it is going to complete all the process. You no need to manually. In case of a standard virtual compute warehouse, then you need to change from one size to another size. In case of a clustering virtual compute warehouse, it is going to use additionally the number of clusters. So by utilizing the number of additional clusters, then you no need to increase the virtual warehouse. You no need to manually increase the virtual warehouse size. It will use the additional clusters and then complete the process. But in case of a standard virtual warehouse, yes, manually you need to increase and then complete the task. Clear or not clear?
Shekhar,
Clear.
can we call this virtual compute is the RAM
Sorry?
or is it CPU?
That is what so far I have explained. There is no RAM, there is no CPU, the physical components in the Snowflake. They have removed that concept. They have introduced this virtual compute warehouse concept in the Snowflake. This is a object in the Snowflake. They have provided the hardware resources in the virtually. There is no hardware resources. This will behave like a hardware resources in the Snowflake virtual compute warehouse. Clear or not clear? Guys, clear or not clear? Say yes or no. Don't be silent, please.
Yes, it's clear.
Yeah. So in case of a while creation of the virtual warehouse, I will show you what is the standard virtual warehouse and what is a cluster virtual warehouse. If you create a cluster virtual warehouse, then manually you no need to increase the size. Automatically it will utilize the additional clusters and then perform your request and then complete your request. And now as suppose let's consider you have around 10 projects in you have a 10 projects in your company in organization. Those 10 projects are using one Snowflake environment. There all the projects are working in the Snowflake environment. Now instead of using a one virtual compute warehouse by the 10 projects, Snowflake has provided the option to create the multiple virtual compute warehouse. That is nothing but instead of sharing the single hardware resources by the 10 projects, instead of sharing the one virtual compute warehouse by the 10 projects, Snowflake has provided the option to create the multiple virtual compute warehouse and then assign each virtual compute warehouse to each project, so that each project will be consuming and utilizing their own independent virtual compute warehouse, so that in all the requests, whatever the project is going to do, they can able to see the very good performance improvement in the all the requests, as hardware resource is not a shared resource in the Snowflake. It is specific to the project. It is independent to the project. So that they can able to see, they can able to perform all the requests, they can able to see, and then they can able to perform all the requests within the time frame line. They don't see any performance issues in the any requests, because individual projects are using individual hardware resources. Hardware resources are not shared across all the projects. If you are working for the one project, you are utilizing your own hardware resources. I am working for the another project, then I am going to use the second virtual compute warehouse. If other is working for the third project, then they are going to use their own virtual compute warehouse. By doing this, they are using their own hardware resource. Like in the on-prem servers, hardware resources are shared across all the projects. But in the Snowflake, they have removed that concept. You can able to create your virtual compute warehouse for your project, and then you can use your own virtual compute warehouse or project, and then complete all the tasks within the time frame line, and you don't see the any performance improvement, you don't see the any performance issues, because you are using your own hardware resources. It is not at all shared across the all the projects. Each and every project has their individual hardware resource, and they are using their individual hardware resource, so that there is no dependency between any of the team. There is no sharing concept. There is no sharing concept of the hardware resources to the multiple projects. They can able to see the very good performance improvement in all the requests of the particular project. So this is about the your query processing layer, guys. Your query processing layer. Clear or not clear? Guys,
Yes.
any doubts? Any doubts? See, now already it is almost time is 55 like that. I'm going to shift into next session. 7 to 8 other batches going. Today we have completed this query processing layer and then database storage layer. We will discuss the cloud service layer by tomorrow. It will take again 10 to 15 minutes. I need to shift into other batch also. If you have any questions on these two layers, then you can ask me, or else we'll end the session for today and then we will continue tomorrow. 3 minutes. If you're clear, and one more thing, this is completely a theoretical discussion. Please go through the recording videos multiple times and try to understand whatever we have discussed here, because this terminology, these concepts are very new concepts, very new terminologies. You have to understand, you have to make habituate, and you have to digest all these things, so that go through the recording video multiple times and then try to understand this. Now tell me if you have any queries, you can ask me, or else we'll end the session for today. We'll join tomorrow. Saturday. Tell me, guys. Any queries?
No query. Thank you.
Yeah, chalo guys. Then we will meet tomorrow.
Okay.
Bye.
Bye.